All right, so as we've learned from quadratics before, sometimes with quadratics we have two solutions, and sometimes we have one solution, and sometimes we have no solutions, right? So just quickly, like graphically, we've just recently seen situations like this, where we have exactly one solution or one root, okay? And, that is where we have a y value of 0. We may have situations like this where we have two roots, okay? And then also possibly situations where we have no solutions. And then we could also figure that out when we use the square root principle. Because if we get a square root of a value that is a negative number here, say like -1, then that's not a real root. That's not a solution, okay? If we have, and when we have negative b plus or minus the square root of b squared minus 4ac. This is the quadratic formula to find the roots, right? All over 2a. When we have a positive value in here, we have the plus or minus. It changes. And then if we have a value inside that square root, that's this part here. Okay, this is called the discriminant. If it's equal to 0, it doesn't make a difference. We only have one solution. So we just have to determine what is a, b, and c, and we know that the equation is written ax squared plus bx plus c is equal to 0, right? So as long as it's written in descending order, so we have a here, here we have b, and here we have c. So we just try that. B squared minus 4ac. So what do we have for b? In this case we have -3 squared minus 4 times a, and times c, -2. I mean, I don't have to go too far to see that this is going to be we're going to be adding. So, whatever that is, it doesn't really matter. Because, it's 16. But it's a positive number. So if it's going to be a positive number, we have plus or minus that positive number, then we say that there are two roots, right? So that would be the answer to the first one. The second one, is it written in standard form? Well, no, we have to set it equal to 0. So we need to add 10 here and add 10 here, so that now we have 0 on the side, so we'll have 0. So we'll have 9n squared minus 3n, and then plus 2. Okay. So again, b squared minus 4ac. And I'm just going to substitute those values in. So I've got -3 again here. Oops. Squared. Running out of space on my pad. Minus 4 times a is 9. And times c is 2. Oh, I wonder, this is going to be 9 minus... Okay, this is more than 9 here. So we can see it's going to be a negative, so there's no roots here. No real roots. Not that are real numbers, anyway. Okay, so over here, let's see. Oh, it's not set equal to 0 yet. So we need to subtract 6x to both sides. So we'll have -x squared minus 6x minus 9 equals 0. If I want, I can change the signs of the coefficient, but I'm not factoring it. I'm just trying to determine what the nature of solutions are, like how many roots there are, so it doesn't really matter. So a is here is -1, b is -6, and c is -9. So b squared minus 4 times a, which is -1, and times c, which is -9. So this is 36, and that's going to be, let's see, minus, right? 36, oh yeah, which is equal to 0. So there's going to be one root here. All right, and basically that shows all the different scenarios, and if we were to graph these, we would see visually that this one here actually touches somewhere on the x-axis exactly once. This one here goes through, it doesn't go through it somewhere. And then this one, it looks like it goes through twice, something like that. All right, that's that.